Hi everybody, we are on page 135 today, 3.6, linear systems in three variables. Okay, so we were doing solving systems when we had two variables before. And when you're solving for two different variables, you need two different equations in order to accomplish that. Now, because we have three different variables, x, y, and z, we need three equations to do that. Now, when we've got all three equations that contain all three variables, basically, this is the way that I always start. I always write the equations up next to each other with some space in between at the top of the board. And I basically just take the first two and I'm going to stack them and use elimination in order to get rid of one of the variables. Well, you can see when you line these up that the y's automatically cancel each other out. So that will leave us with an equation in terms of x and z only. Okay, we add straight down x plus 3x to get 4x, negative 2z plus 1z is negative z, and 13 minus 9 is 4. Now we'll do the same thing here with the second two equations, and because we eliminated y in the first set, we're going to eliminate y in this set as well. And it again just so happens that these two will automatically eliminate the y, just like it did in the first two equations. And we're left with 5x plus 5z is equal to 30. Okay? Now, if you want to, you can just reduce everything by dividing by 5. And if we do that, we'll get x plus z is equal to 6. So we can use that equation there along with the other equation that we just got, because both of them now only have x's and z's in them. So notice what happens is that when I divided that second equation in x and z by 5, I get x plus z equals 6. And here, my z's automatically get rid of each other. So I end up with 5x is equal to 10 and x is equal to 2. And once we solve for that first variable, now we can start to back substitute. I can use this x equals 2 in my x plus z. So now 2 plus z is equal to 6. So z is equal to 4. Now that I know what x and z are, I'm just going to plug them into the very first equation to solve for y. So 2 plus y minus 2 times 4, because z is 4, is equal to negative 9. 2 plus y minus 8 is equal to negative 9. So y minus 6 is equal to negative 9. Therefore, y is equal to negative 3. And the solution then would be written in a set of coordinates with x first, y next, and z last. So x, y, and z. Okay, now we run into example 3 where we don't have all the variables in all of the different equations. The first variable is missing a z, or the first equation is missing a z. The second equation is missing an x. The third equation is missing a y. Okay, so in order to avoid some huge problems here, what we're going to do is take the simplest equation that we've got there and look at solving that for either x or y and making a substitution. So if I use, say, this equation as one of my equations in my elimination process, that means that this equation over here to the far right has to also be in terms of y and z only. So the way that we're going to accomplish that is by taking this first equation here and solving it for x. So x is equal to 6 minus y. Now that we know what x is equal to, we're going to come over here to the equation on the far right and rewrite it in terms of y and z. So the x is gone, and we end up with an equation in only y and z. And notice y and z is going to match perfectly with the equation in the middle, which is only in terms of y and z. So there is a reason that you start something like this with substitution. Okay, so we end up with negative 4y plus 5z is equal to 32. Okay, now notice, before I go any further, what I would definitely like to point out is in each one of these equations, in each one of these original equations, the x, the y, and the z are on one side of the equal sign, and the constant is all by itself on the other side. You need to make sure that, first and foremost, that is the formation that your equations are in. Secondly, you need to write them in order x, y, z. So when you stack them, x is above x, y is above y, and z is above z. You can't subtract an x from a z or a y from an x. You need to make sure that all of your equations are in the same order, x, y, z, or a, b, c, or whatever your variables are in order. So the same thing applies here. Even though we might be missing a variable from all of these three equations, we still have the variables on one side of the equal sign separated from the constant on the other side. Very important. Okay, so moving on. Now I've got my middle equation in y and z, and my new equation here in y and z. So I can put those together, and I can eliminate either y or z, whichever one I find to be maybe more feasible, meaning maybe a little bit easier. Okay, doesn't really matter. So I'm just going to eliminate the y. Okay, so if I do that, the number that both 3 and negative 4 go into evenly, the least common is 12. So I'll multiply the top equation by 4 and the bottom equation by 3. So I would get my new system here, an entirely new system, distributing the 4 all the way through and then distributing the 3 all the way through. Okay, now I have gotten rid of my y, and I get the fact that 7z is equal to 56, so z is equal to 8. Now I can use that in this equation right here and solve for y. Okay, so negative 4y plus 5 times 8 is equal to 32, and negative 4y plus 40 is equal to 32. And if I subtract 40 from both sides, I get negative 4y is equal to negative 8. Therefore, y is equal to positive 2. Now I can use that y and this equation for x over here on the far left, and I can solve for x by plugging in y equals 2. So x is equal to 6 minus 2, x is equal to 4. So we have 4, 2, and 8 for the solution set for example 3. So what I'm going to do is pull a homework problem in X, Y, and Z, and we're going to do another one together, okay, just so you get the idea of how these work out, okay? So I'm looking at number 11 on the homework 137. So we have 2x plus 3y minus z equals 21, and then x minus y plus z equals 1, and x minus 2y minus z equals 5. So I just wrote them in order, the way that they were given to me, and I'm not going to stop and think about how am I going to move these around, what do I want to pick to eliminate. I'm just going to put the first two together, and after I write them stacked, I'm going to see what might be the easiest variable to eliminate. And when you look after you stack, the z's naturally cancel each other out. So that answers our question, leaving us with 3x plus 2y equals 22. Because I eliminated the z from the first two, I'm going to eliminate the z from these as well. So x minus 2y minus z is equal to 5. And again, the z's naturally cancel each other out. 2x minus 3y is equal to 6. So I'm going to put these two together, and depending upon what looks easier to eliminate, I'll make the choice on what final variable I want to get rid of. Well, the y's, I've got a positive 2y and a negative 3, so it would be easier to just eliminate the y. The least common multiple is 6, so I'll multiply the top by 3 and the bottom by 2. And my new system, distributing the 3 all the way through, is 9x plus 6y equals 66, and 4x minus 6y equals 12. Now my y's naturally cancel each other out, and I get 13x is equal to 78. Now let's see, 78 divided by 13 gives us that x is equal to 6. Now I'm going to start back subbing, okay? I'm going to pick, first of all, a different color. I'm going to pick that equation to plug x in and solve for y. So 3 times 6 is 18. And when I subtract 18 from both sides, I get 4. Divide by 2, and y is equal to 2. Now, one of the 3 originals, I can plug in x and y and solve for z. So I'm going to use the one on the upper left, okay? So 2 times 6 is 12, plus 3 times 2 is 6, minus z equals 21. And then I get 22 minus z equals 21. Negative z equals negative 1. Therefore, z is equal to 1. And my solution set, x, y, z. Okay? So, hopefully, that was simple. Don't make it hard. It is not hard. Okay? It is very simple. Keep your stuff organized, and you will have very little trouble with this. Okay. See you guys.